these are the features which I have taught you in my previous class. It's classful routing protocol. It supports VLSM, CIDR, manual route summarization, equal cost load balancing, and AD value of OSPF is 110. It's going to use 2 multicast addresses. These are the things I've told you. Then I told you about the algorithm that Ospf is using to calculate the best route. And then I told you about what are the tables, or you can say topology tables, that are inside the Ospf router. So there are 3: neighbor topology, router topology, and neighbor topology table, neighbor table, topology table, and routing table. Then I told you about Ospf neighbors, how basically Ospf is establishing a neighbor relationship before exchanging the routing updates. So I told you it's using a multicast address 224.0.0.5. And if you have to check the neighbor relationship after creating it, so it's going to use the command show IP Ospf neighbor, which I'm going to tell you again. So then I told you about the packets, which must be same on both the routers, or on both the routers from R1 and R2 to establish a neighbor relationship. So these are the packets: subnet, area ID, hello and dead interval times, authentication, and area stub flag and MTU. And I told you by default Ospf sends hello packets after every 10 seconds on the Ethernet network, and a dead timer is 4 times the value of the hello interval. That means 40 seconds is the dead timer for Ospf. After that, the router is declaring the neighbor as dead. And then I told you there are 6 different states of a router. How do we, when they are about to exchange the information, they are about to, create the neighbor relationships, exchange information. So I told you about init state, where a neighbor or a router sends a hello packet to the neighboring router. Then when it replies back, that's called as 2.1, and then they start sharing the LSDB, which is link state database, and both the routers from R2 to R1. Then exchange state, then what's loading state, and full state. Then I told you about Ospf areas, how basically Ospf areas are going to work. It's not about the physical area, it's a logical grouping of routers. We logically configure or just put them in one area, but the network is within the same particular campus, or you can say within the same area physically, but logically we are dividing that into areas. Based on that, we share routing tables. So why we are basically dividing the Ospf network into areas, because you know that in Ospf, routers share their entire network topology, so it can affect the network performance, and it can also affect the bandwidth and delay, or you can say it will be it will be more prone to, you can say, performance will be very slow. So these are the things that will happen, and that's why we divide it into equal parts, and then we have a central router with the help of we share the routing tables, or you can say network topology. And today we have the last topic of Ospf in terms of theory. So these are the last theoretical topics that we do have in Ospf, and then we'll directly go and start configuring your Ospf network. Okay.
Okay.
So let's go. And first of all, we have LSA. What is LSA? LSA is, I've told you before, even it's linked in the init state. I told you there are something. So link state advertisements. Just so link state advertisements are used by Ospf routers. So those routers which are configured with Ospf, it's being used to exchange topology information. So you need to remember these things. This LSA, which is link state advertisement, basically this LSA is used by the OSPF routers to just exchange the topology information with the neighboring routers. After a neighbor relationship will be established, LSAs are going to work. They share their topology information to each router in that network. So each LSA, which is nothing but link state advertisement, contains routing and topology, routing and topology information to describe a part of an OSPF network. So each LSA contains routing and topology information, which is going to describe, or which will, which will describe, or you can say there is another word like, which will make you sure that this is the part of this particular network, an area. So LSA will be shared within an area, and which is basically a part of an OSPF network, which is going to describe that thing. That is about LSA. Okay. Another example, so when two routers or two neighbor, N-E-I-G-H-B-O-R, as neighbors decide to exchange, exchange routes, or you can say routes, they send each other a list of all LSAs in their respective topology. Database. Then what happens, each router then checks its topology database and sends a link state request. Link state request, which is LSR message, requesting all LSAs not found, which are not found, or all SLSA which are not found in its topology table. I will make you understand this. Other routes, or you can say routes, other router responds with the link state update, which is LSU, that contains all LSAs requested by the other neighbor, N-E-I-G-H-B-O-R. So this is the explanation of these, all the three types. Now, very smoothly, very clearly, I'm gonna just try to make you understand this concept. Who left? Sana is not here? What happened? Hana and Sana.
Her Amazon is not working.
Mm-hmm.
It's just suddenly stopped, and now she's trying to make it work.
Oh. Okay. So I'm going to tell you in very simple ways what LSA is, LSU is, and LSR is. Today, what a deal. Yeah, click OK, Hadil, click OK. This meeting is being recorded by me. I'm going to upload this tutorial on YouTube so that you can get it even. Click OK. All right. So I will take an example. Suppose that we are having one router here, another router here, and I'm going to take example of just two routers only. This is R1 and this is R2. We are having the directly connected network to this 1, 2. Okay. So this is, for example, 10.0 network. It's 20.0 network. And this is, now I have another network here, which is, for example, 30.0 network, and this is 40.0. And it can be, here it can be 192.168, and here it can be 172, and something like that. So first of all, when you configure, are you here with me? This is a very important concept. Are you here with me all?
Yes.
Yeah, great. So what happens here, when you will configure, suppose that, imagine that OSPF is configured and the neighbor relationship has made. Next thing what happens is every router, whether there are more than one router over here, so I will say there is one more router here. So this is R3. So every router will send an LSA to each other. This R3 is having the links to R2 and R1, so it will advertise the LSA, which is link state advertisement. So what is that LSA? LSA is, suppose that there are two different networks connected to this also. So this R3 knows that I have these two networks in my database, right?
Yeah.
So it will advertise both the networks, or even if there are any other networks, it will, whatever is. So simply you will understand by whatever is there in this particular router, whatever the network topology is there in this particular router, it will advertise that. So that advertising thing is called as LSA, which is called as link state advertisement. So in both ways, it will advertise. It will tell those routers, I have this thing. Do you need it? Are you understand?
Yeah.
You understanding? So it will tell both the routers, I have this thing in my particular memory. Now, do you need it? And if you need it, which information do you need? So when the information will reach to R2, for example, it's between R3 and R2, it will check which information. For example, there are some entries which already this particular R2 is having, but one entry is which is not stored in the routing table of R2. So it will not take the information which is already stored in R2. It will take only that which is not stored in the routing table of R2. So when it will match, so both the databases will match. All right. So whatever is there, they will not share that. So only R2 will take the information which is not there in the routing table of R2. You understanding? So when R2 will just check the database, next thing is when R2 will get like there is one entry which is not in my particular database, it will send the LSR to R3, which is called as link state request. Now, when they will match the database, when it will check the database that no, I don't have this thing in my particular routing table, it will just see this entry is not. So it will send the link state up request to the R3 that I don't have this particular entry in my routing table. Please give it to me. Are you understanding? Hello?
Yes.
So
Yes, I do
when the
understand.
request will be reached to
Yes.
R3, it will just send that entry with the routing table with, I mean, it will just give you, or it will send back the particular entry and it will store it into R2, but that request is called as, so R3 will send an update and that's called as LSU, link state update. Are you understanding?
Yeah.
So that's how everything is going to work in OSPF. So simply, I'm going to tell you simply. So in the same way, what happens here, so in the same way, R2 will advertise his own particular routing table to R3. Or now, R1 is having two directly connected networks. So whatever is there in the database, it will just advertise to neighboring routers. So this router will just check the database. So whatever the entries are there already, so it will not take them. It will take only those entries. And when it will match, or when it's going to match the database of LSDB, which is having which is already stored in R2, it will just check what are the entries which are there. So if there is any entry which is not stored in R2's database, it will just request for those entries to R1, and that is called as, so when R1 advertises, it's called as LSA. I'm advertising this thing. You understand? And when R2 gets the information and it just matches the database, and if there is any entry, it sends the request that I need this entry only, or there are two IP addresses which I don't have. There are two networks which I don't have. It requests that from R1, to R1. And then it's called as LSR, which is link state request. And when R2 receives the request, it is sending that update. So what's that update? It is just sending that particular information which R2 is not having in his routing table. Are you understanding?
Yes.
So that's what LSA is, LSU is, and LSR is. Clear? It's something
Yeah.
now. You are my students. I have the knowledge. I'm sharing it with you, right? Suppose that we have Ali, we have Hana, and I am here. I'm whatever is I have a memory, right? You are having a
Yeah.
memory. Ali is having also a memory. So Ali knows. Maybe I don't know anything that Ali knows, or you or Hana. So you might have some information which I might not be having. So what I can do is whatever is in my mind, I will try to give you the information about that, and then I will advertise it. That is, I'm just advertising it. I'm having this particular thing. Would you need it? So you will check. Yes. Okay. All right. This information I do have. So I don't have this information. So you will request me, sir, please give me this thing. That's called as you're requesting. That's called as, I'm telling you, that's called as LSA, link state advertise. I'm advertising something. When you come back, when you send me a request, sir, I have all the things, but I don't have this thing. That's called as LSR. You're requesting me to give me this particular information, which is in your memory. So what I will do is I will receive the request and I will send you an update. What's the update? I will give you that information. So that's what all these three things are. Clear?
Yes.
Okay. Everybody's here?
Yes.
All right.
Yes.
Let me take the attendance. You people are rooming today. Going, coming, going, coming. So that was the concept of, OSPF and rest of the information. So we'll directly go now and start our OSPF configuration, and I'll show you how you can do that. OSPF configuration. kindly be with me and remember the things that I'm telling you now, what we have to do or what you have to do while configuring it. So configuring OSPF first, which is just OSPF first. Suppose we have given just an autonomous number 1. All right, so OSPF basic configuration is very simple. If you go with the basic configuration, just like with other routing protocols that we have covered or we have gone through them, like so RIP, EIGRP, these are the protocols which we have gone through. So first thing is we need to enable OSPF router. It means we need to enable the OSPF routing protocol on any router. So this is done by using the command. So command is here. Router, same like we did before, router OSPF. And here we're not using autonomous number. We're using process ID. Process ID. Router OSPF, that's why I told you right now I took process ID as 1. So router OSPF process ID, it can be 1, 2, 3, 4, I will tell you. So next thing is, secondly, we need to define, in capitals, we need to define on which interfaces OSPF will run and what networks will be advertised. So these are the 3 things we need to tell. So on which interfaces OSPF will run, and thirdly, or you can say on thirdly, what networks will be advertised. These are the 3 things that we have to tell. So this is done by the network command, network IP address, wildcard mask. Here wildcard mask is very important. And the very important thing here we do have to add is area ID. So far we never did this, but this is the first time we have to add. That's area ID. When you advertise the network, so far in RIP and EIGRP, we've been using network, then either we can use the network ID with wildcard mask, or we can simply use the network ID only. But here, this is the complete command that you have to use. You have to give the IP, which is network ID, plus the wildcard mask, and plus the area ID, which is very important. So what is this area ID? It's same like as autonomous number. If you want that these 3 routers, 4 or 5 or 6 or up to 10, 20, 30 will be in the same area, so you have to choose. I told you what areas are. They are logical grouping of routers. Logical grouping, we are dividing an OSPF network into small segments, so that it will be very easy for routers to share their routing tables like LSA, LSU, and LSR. So that's why we have divided OSPF. That is why OSPF is basically divided into areas. So we need to give the exact area ID. So if it's here we have these 4 routers in the same area. We need to give the same area ID. This is very important. Okay? Remember this thing. Clear?
Yes, clear.
But note the OSPF process number does not have to be or need to be same on all the routers. The process ID basically I'm talking about. If you have to establish a relationship, it's not necessary that you can just implement the same process ID on each router in order to establish a neighbor relationship. But the very important thing is the area ID has to be same on all the neighboring NEIGHBORNG neighboring routers in order to become neighbors. Why it's giving me D every time? In order to become neighbors, so your area ID has to be same. Okay? So this is very important point you need to remember. So whenever you configure OSPF, process ID or process number does not have to be same on all the routers to establish, but if you talk about area ID, it's very important that it should be same on every particular router. Okay? Clear?
Clear.
Yes.
So let's go through the first particular topology and we'll see how basically this OSPF, a basic topology I'm gonna make. So Cisco packet tracer. I hope you're gonna be with me and see what's basically happening. All right, so I'm here. I'm gonna take one router here, another router here. I'm gonna take just 2 networks for now. All right, a 1 switch, 290. Let me go up. This is my 1 network. You can add more, not an issue, but let me go through just 1 first, here 1, and then you can take 2 devices. Here you can take also 2 devices. And then, as you know, how to connect your cables to the respected ports, or you can say interfaces. And okay, and then here we need to add some serial ports, 2T, and just drag and drop, you know it. So turn on the router again, and then go over here, 2T, turn off the router first, add the ports, and close it again. All right, and then we will go and add the serial port to slash it. That's it. And next thing is to give the IP addresses. So 10.0 here, and here it's 192.168.20.0 This is class full for now, but later on we'll go with class less as well. Remember this thing. 24. And here we are going with 172.116.0.0/16. Oh, we have only 1 network. Why we are giving a lot of networks? Delete this. All right, so this is B class full address, and this is C class full address. And here also, yep, we can use 172.16. No, we can say, yep, 10.0.0.0/8. Okay, and after that, here will be .1, and here will be .2, and here will be also .1, and here will be .1. Clear? This is for this, this is for this, and this is for this one and this one. So first of all, what we're going to do is we have to, as always, configure the IP addresses for each interface. So enable, move a bit. So config terminal, interface gigabit Ethernet 0/0/0. Very fast. I'm going to do it because
Very difficult.
Hello. Sir, we can't hear you. What happened? Hello, is there anyone here?
yeah, I'm having a network problem. I hope this is, hello?
Hi.
Are you here? Can you hear me now?
Yes, we can hear you now.
Oh gosh. What's this issue? Everybody's here now?
Wait, Hannah was dropped.
Okay. I don't know why it happened. There was just a problem in the internet connection of my computer. Okay, so this was the interface. We are going through the IP address configuration only. So first, to exit, we will go to interface serial 0/1/0, right? And IP address, if I'm wrong, please let me know, 10.0.1, right? 255.255. Am I right or wrong?
Yes. Right.
No shit. Exit. We are done with this, so exit from here. You can say exit. So I can say copy startup, not startup, copy running configuration to startup. Allows this. I'll minimize it. And I'll go here to CLI, and then here I don't want to enable anything, but if you want to give a host name, you can give configure T host name, for example. I can say it's botnet 1. That's it. And then I will go to the interfaces of it. First thing, I will just configure the interface of the left-hand side, which is serial 0/2/0 and IP address 10.0.0. 172 with the subnet mask 255.0.0.0. No shit. Now interface is up. An interface gigabit Ethernet 0/0/0 IP address, which is up now. IP address, it's 172.16.0.1 with the subnet mask 255.255.0.0. No shit. Clear?
Yes.
So copy running configuration to startup. Khalas. And here also I'm gonna name it. And is up router. So config terminal host name botnet. I can say zombie 1. That's it. Exit, copy startup to running. Oh, always doing the mistake. It's running to startup. Now we are going to start OSPF configuration. Okay. So this is the basic. If you want both the routers in the same area, we want both the routers in the same area, then they should be able to communicate. So what we're going to do is here, I'm going to first of all, this is my first router. So I will go to config terminal. As I've told you, there are only 2 commands that we need. First is router OSPF and process ID, suppose 1 by default, or you can say I have set it 1. You can set 2, 3, 4, it's up to you. Next thing is network command, which we have to advertise. So on this router, how many networks we do have?
3.
It's 10. It's 192. No, only 2.
No, yeah. 2 connect.
10.0. But here instead of subnet mask, we have to calculate, or we have to write, or we have to mention the wildcard mask, as it's a classful IP address and it's C class. So you know that if the subnet mask is 255.255.255.0, that means all 255 will be zeros and the host part will be 255. And then the very important thing, sorry, Mary, not Mary, the very important thing is area. So by default, the first backbone area that we do have is area 0. Always you should start from area 0. This is called as the backbone area. So that's area 0. In the same way, we will add another particular network, which is 10.0.0.0. And if it's class A IP address, then you know that by default there are only 8 networks. So that means all the 8 have to be in 0 position, or we need to add 0 in the 8 bits, and then rest of these 24 bits, how much they are?
255.
255, 255, and 255 will be the wildcard mask, and you have to hit enter it. That's it. And exit. Khalas. Okay, that's the router first configuration. Auto summary, or this is just one network we have, and we have class full, so you can add it later on. But right now, this is the basic configuration. We can go and then configure terminal, router, OSPF. Now, this process ID doesn't want to be same. If you want, you can change the process ID. If you want, you can put the same, doesn't matter. But now, if you are advertising a network which is 172.16.0.0 with, now if it's B class address, you need to remember this thing. So 172.16.0.0/16 is B class address by default. 16, so subnet mask is 255.255.0.0. So if you have to use the wildcard mask, it will be reversed. It will be 0 while there is 255. It is going to be 0, 0 over there. While there is 0, it's going to be 255, 255. Okay?
Okay.
So it's going to be 0.0.255.255. And very important thing is area. And again, the area should be same. Area 0. then only a neighbor relationship will be formed, area 0. And again, network, which is the network which is 10.0.0.0/8. We are using just classful IP address, and again we have to mention 3 octets as 255.255.255. Only the network port will be considered as wildcard mask, and hit enter. That's it, and exit. And you see, process first NBR and serial this from loading to now full loading done. And at the same time, you're going to have the neighbor relationship with the neighboring router. And now LSA and LSR and LSU is going to work when the neighbor relationship will be formed. And if you want to check whether there is any neighbor or not, you can use a command show IP Ospf neighbor and hit enter. You will see this is the neighboring table that we do have. Here we go. So we have on this router, the neighbor is, you can see, 192.168.10.1. This is the neighbor that we do have. So address says this is network, sorry, this is the network ID. This is neighbor ID, sorry. So dead time is here, and address of this is this IP address. So this is neighbor ID that we do have. 192.168.10.1, primary state is full, dead timer is 38, and then 10.0.0.1, and on the interface is through this interface, which is serial 2/2. In the same way, when we will go here, you can see loading is done automatic. So you can say, even if you don't want, you can say do show IP OS here. But the problem is you have to write each and everything yourself because it's not giving the help. So it's better to come here and say like show IP Ospf neighbor, and you will get the same thing. So you will get the neighbor of another network. So you will get neighbor ID here, which is the IP address of this network. Full state dead timer is 32. Address is 10.0.0.2, which is here. And interface is from this interface it's going through. All right, that's Ospf neighbor. So that's the first basic topology which we have configured with the help of Ospf open shortest path first configuration using area ID 0. Okay. So files, save on desktop, CCNA topology. So Ospf, this is the basic topology with a single area. You got this thing, and now the very important thing is, yeah, we can just go and configure the DHCP server also. It takes just 2 minutes. So IP DHCP pool. This is zombie. I can name it as Zoom network 192.168.10.0 with the subnet mask 255.255.255.0. Default router. It's now 192.168.10.1. Colors. Exit from here. Exit from here. And then we can say copy routing configuration to startup. Are you all here with me?
Yes.
Yes.
I'm hearing the noises about joining. Something is wrong today, I guess.
Yeah, I think the application is, I don't know, there's a problem with it.
Yeah. IP DHCP pool, it's botnet. I can name it as botnet network 172.16.0.0 oblique subnet mask is 255.255.0.0 and default router is 172.16.0.1 and exit. That's it. Exit. Copy running to startup. Exit. That's it, and we'll go on to computers and go to desktop IP DHCP. And then we'll go to desktop IP DHCP. It's gonna get the IP address here. So over here also desktop IP DHCP. You get the information here of the network that we do have. Over here also, you can click on DHCP and it will get the IP address with all the information. And then we'll try to ping the network from this PC. We'll try to ping this PC. So command prompt, so it's ping. So it's gonna be 1 here, that means 2 or 3 will be here. So it's 172.16.0.1 first, which is pinging, which is the default gateway address, 2. And it is just sending the request first time ARP request. So you can see now, Control C again, when you ping it out, so it's gonna ping. Then 0.3 again, it will take some time in the first request, echo request. Oh, here we go. So that means our network is working, right?
Yes.
Now go through it and try to add 2 subnets and try to configure the Ospf network. All right, so you can use simulator here. You can take simulators here. You can start it. It will ping automatically, or you can take packets from here. If you want to ping in this way, also click over here, and I want to ping it in this way. It's checking the connectivity. Even in this way also, you can see everything is working well. This is simple PDU. This is complex PDU. And then if you want, you can use complex one from this to, you have to use destination IP address and all. We just want to use just simple one from this particular PC to, it closed it, to this particular PC to this particular PC. That's just sending the packet. If you want to transfer the packets from this PC to any other network, it will automatically work and check the connectivity. And you can see packet is just getting forwarded from here. So when you click on simple, it will give you the packets, 2 packets, 1 click over here and 1 click over here. You can check, you can see it's just giving you the path through which is, so it's here destinated. Got it? So simulation is used just to check the connectivity on both ways. You can see now it will just send the request back. Okay. And when you open the simulator, you can see type. What are the protocols? It's always, I told you, ping is using ICMP protocol. And it's giving you all the information from which PC to which PC, router first, switch first, router first, switch first, and so on. Okay?
Okay.
You can start the simulation here. I mean, stop and then close it. So go ahead and try to do it. I'm giving you 10 minutes. In 10 minutes, you can do it, right? But add 2 subnets. And with this, you can say the classful IP addressing. Go with it and try to configure it. So this is a basic topology where we have used only the backbone area ID, which is 0. Okay?
Okay.
Okay. So 2 subnets in each router.
Yeah, 2 subnets in each router, even if you have to, check show IP OSPF route, you can go, what happened? Show IP OSPF. Oh, sorry, show IP OS, show IP route. ospf root again.
Brief,
Yep.
I guess.
Just show IP root ospf. You can see the root via this thing. This is again one more command which will help you to check from which network you are learning. You're learning the net. I mean, from which router ID of which router you are learning. So that's the particular network on this. If you want to run the same command on this router, you can say show IP root ospf, and you will see O and 192.1. Even you can say show IP root. It's going to give you root, and you can see here now if it's ospf, it's using O instead of D because D is EIGRP, R is RIP. So O is here. You can see this is 192.160, and you can see the AD value is 110 and cost is the metric. So that's cost is only 65 to reach 10.0.0. In both ways, cost should be most of the time same. So IP root, yep, cost is same because there is only one router. Okay.
Okay.
All right, go ahead with it and use two subnets. This was about the basic configuration. Do it fast.